I welcome you all, dear children. This is about continuing the topic that is the physical properties of haloalkanes and haloarenes of class 12th. Okay, so as we were doing, children, the melting and boiling point. So this is further continuation of that topic only. So, children, when I talk about the boiling point of different halides, okay, so I have told you I'll be comparing the parent hydrocarbon with these haloalkanes or haloarenes. So children, if I talk about a parent hydrocarbon, like in case of CH3X, the parent hydrocarbon is CH4. In case of CH3CH2X, the parent hydrocarbon is C2H6. And in case of this one, it is C3H. How many carbon atoms will be there? 7. C3H7, so it will be C3H8. Here it is C2H6 and here it is CH4. The three parent hydrocarbons of these three haloalkanes. So children, the boiling points of these alkyl halides will be more as compared to their parent hydrocarbon. Okay, so it is shown in case of this like the first thing I told you, boiling point of methane will be less than methyl halide. Boiling point of ethane will be less than ethyl halide, and boiling point of propane will be less than propyl halide. Now children, if I compare these three halides, so I have told you as the size increases when the number of carbon atoms increases. So as the size increases, the size of this one is greater than this one, the size of this one is greater than this one. So you can see in this graph, children, as the size increases, boiling point also increases. So boiling point of this one is more as compared to this one, and boiling point of this one will be more as compared to this one, because the size of this one is greater than this one and the size of this one is greater than the size of this one. Okay children, so this is all about why I'm telling it on the basis of size, because I've told you children in my earlier video that as the size increases, van der Waals forces of attraction increases. जब forces of attraction increase होंगे तो bond strong होने की वजह से break करने के लिए ज़्यादा energy लगेगी. Then the boiling point will be more, children. Next, if we are taking the same alkyl halide, children, here if we are having CH3I, R is CH3, suppose. Here it is CH3Br, here it is CH3Cl, and here it is CH3F. Then children, as you know, if question comes in the board exam, children, arrange the following alkyl halide in the decreasing order of their boiling point. Suppose it is CH3I, CH3Br, CH3Cl and CH3F. So children, you can say that CH3I will be having more boiling point as compared to CH3Br, which is more as compared to CH3Cl, which is more as compared to CH3F, because here the alkyl group is same, that is CH3, but the size of iodine is more as compared to the size of fluorine. So here the size will be more as compared to this one. So when the size is more, the magnitude of van der Waals force of attraction will be more. So the energy needed to break the force of attraction will be more. So the boiling point of this one will be greatest as compared to all these. Okay. So size of iodine is more as compared to bromine. Bromine is more as compared to chlorine. Chlorine size is more as compared to fluorine. So this is why the boiling point of this is maximum and this one is lowest. Children, this kind of questions come in your board exam. Arrange the following increasing order of their boiling point, or they can give you this type in case in give reasons also. This type of question give reason also, that why the boiling point of this one is maximum, this one is least. So this you have to explain on the basis of size, that is on the basis of van der Waals force of attraction. Now children, the next one is I'll be arranging them on the basis of their like boiling points. So here children, it is you can see here we are having the same halogen X. Suppose it is fluorine, fluorine, fluorine. Okay, so same halogen X is there children, but now the alkyl group are different. Here children, you can see this one is having greater size as compared to this one, and this one is having greater size as compared to this one. So children, here the boiling point of this one will be greater as the size is greater, so the magnitude of van der Waals forces will be maximum as compared to this one, and this will have more van der Waals force of attraction as compared to this one, because the size of this is maximum as compared to this, and this will have more size, greater size compared to this one. So more van der Waals force of attraction, so more will be the boiling point. Okay children, so this is how we arrange them. But children, when we talk about isomeric halides, so these three are the isomers. Okay, this is the main one and these are the isomers. So these three halides are the isomers of one another. So children, what happens here, you can see branching is there, but here we have straight chain. So children, as you know that in straight chain the surface area is more as compared to this one. Here the surface area is minimum. So children, with the decrease in surface area, van der Waals force of attraction decreases, and with the increase in surface area, the van der Waals force of attraction increases. So children, here the surface area is least, so van der Waals force of attraction will be least. Here also the surface area is less, but as compared to this one, the surface area is more, but the surface area of this one is less as compared to this one. So children, the boiling point will be least in case of this one and maximum in case of this one, because this have the maximum surface area, so maximum van der Waals force of attraction, so more energy is needed to break the bond as compared to this one and this one, because here the surface area is less, so the van der Waals force of attraction are less, so less energy is needed to break the bond, so the boiling point is less children. So this one more surface area, this one less than this one least, so this maximum, this one will be in between, and this will have the least boiling point. Next children, generally the boiling point, if we talk about chloro or bromo or ido, so as the number of halogen atoms increases children, the boiling point increases because the size increases. Okay, because chlorine is having more size as compared to hydrogen. Here we are removing one hydrogen, you can see one hydrogen is removed and one chlorine is being added. So the size is increasing on adding chlorine and removing hydrogen. So the boiling point also increases children. Now, so this one will have maximum boiling point, this will have least boiling point. Okay, next, boiling point. If we talk about the boiling point of these three isomeric dihalobenzene. Okay, so children, here the boiling point will be maximum, because in para it is having more symmetry, it is more symmetrical children, so the boiling point will be maximum. So this chlorine lies within the same crystal lattice, जो ये क्लोरीन है within the same crystal lattice lie करता है और ये दोनों सामने हैं, so they will have more symmetry. So being more symmetrical, the boiling point and melting point will be highest in case of para isomer, and here it is least symmetrical children, so it will have least boiling, no, this is least symmetrical, so this will have least boiling point as compared to ortho and para. So meta will have least boiling point, para will have maximum boiling point, and this ortho will lie in between. Why this is having more boiling point? Because it is symmetrical and lies within the crystal lattice. Okay, children, so this is about the boiling point. So further remaining four physical this one properties of haloalkanes and haloarenes will be doing in my next video. Thank you, children.